All right, I'm working on antiderivatives, and one antiderivative that shows up in applications sometimes that's useful to know is the antiderivative of secant x. There's no trig function that I can just come up with off the top of my head whose derivative is secant, but it turns out there's something strange that I can do to this, an algebraic manipulation that will allow me to use a u substitution to find this antiderivative. Or I could just memorize it. Either way is fine. Going with the algebraic manipulation, I think this is a little bit easier for helping to remember this antiderivative long term. But not everyone will do it. What you do is you take secant and you multiply it by 1 in a special way where you're multiplying by secant plus tangent in the top and secant plus tangent in the bottom. When you do this, the value is that the derivative of this bottom part is now secant tangent plus secant squared. And when you multiply out the numerator, you get that exact thing. You get secant squared plus secant tangent. So we'll be able to let u equal the stuff in the bottom, and du will handle the numerator. We'll get the answer. I'll go ahead and write this out as secant squared plus secant tangent in the top. And then, like I said, I'm going to let u equal the stuff in the bottom. So du is now the stuff in the top. I don't think I'll write that out. Just notice du dx is equal to exactly this numerator. So du is equal to exactly the numerator times dx. So now what I have is the integral of 1 over u du. And now I know the derivative of natural log of x is 1 over x. So this becomes ln absolute value of u. And I'll go ahead and rewrite what u is. Secant x plus tangent x. Plus the arbitrary constant. So this is the antiderivative of secant x. You can take the derivative of this thing and verify that you do get back to here. There are some absolute values there that bring up some interesting questions, but you do, in effect, get back to here. The same thing can be done for cosecant. If you take cosecant over 1 and multiply by cosecant plus cotangent, you have a similar thing happening here, so that's a good one to try. And then you can easily look up the solution to make sure that you're getting to the correct answer.